Hey guys, Mr. Bouchard here, and today we're here to talk about stream erosion. Alright, so this picture here kind of tells the story. So, pretty much we're going to talk about how does a river get to this state you're looking at, which it actually is a very mature stream at this point. So obviously there's erosion that happens, and also changes in speed in the river. So let's talk about these and talk about the sediment transport that happens in rivers. Okay, so running water, as you guys know, is a dominant agent of erosion, even in arid climates. Arid climates, I mean obviously desert-like climates, very dry environments. They can get heavy rainfall, and obviously that can carry sediment. Also, streams can carry sediment in three different ways. First way is by solution. These are your dissolved minerals and ions that are transported with the river at the same speed. Suspension, those are the ones held off the bottom. Small particles such as colloids or clay and silt are lifted up off the bottom. And that's sometimes you can see a murky color in a river after especially a heavy rainfall. It's carrying those smaller size sediment. Rolling and bouncing are your large solid sediments, sand, pebbles, cobbles sometimes a little bit, but boulders don't move all that much. But either way, any big sediment is going to be rolling and bouncing on the bottom. And you guys remember we talked about the appearance of river rocks. They tend to be rounded because again, all those sharp edges come off when these rocks are rolling and bouncing on the bottom. So here's just a look at where these different types of sediment are. So again, the bed load are the ones rolling and bouncing on the bottom. Suspended load are the ones that are held up above the surface, the silt and clay. And then dissolved are the ones you can't see in the water, which are actually ions, which are charged particles floating in the river. Okay, this used to be an animated thing. Unfortunately, Flash has expired, so we can't see that anymore. But again, this is just another artist rendition of the same thing. So velocity in streams, if sediment is to be transported by water, the water has to be moving, obviously. Once it stops, it's going to drop. All right, and that's where we're going to get into the final part of the chapter, which is deposition. Stream velocity is stream of speed of the stream, or the rate of the stream. That's the different ways that they can say it. As velocity of the stream increases, the amount of sediment transported increases. Also, as velocity increases, the size of the particles transported will increase also. And that's the graphs for that, exactly what I said. And don't forget, you have your reference table, page 6. Make sure you know how to read that chart. Remember, it's a log scale, so counting by powers of 10 between each big grid. Alright, so make sure you guys are understanding that. Use the ones that are labeled like the 0.0004 to remind you of that, okay, when you're figuring out the scale. So those that live on Long Island obviously know this water park, alright, local water park called Splash. Alright, there might be other water parks you've been to. But basically, we can use this as an analogy for where the sediment and where the velocity of the river is going to be the greatest. So where the sediment is going to be deposited, where it's going to be eroded. All right, so slope. As slope increases, the velocity increases. All right, and anybody that knows Splash, cliff diver, 80-foot slide, very steep slope. So that's the fastest slide in the whole park. Whereas something like the lazy river, just water jets pushing you along, very low slope, so low velocity. All right, so you could use that as an analogy in your head to remember that. So as slope increases, velocity will increase. Also discharge. Discharge is the amount of water coming out of the stream. So as discharge increases, velocity of the water will increase. That makes sense. So just like a water slide, if you turned up the water on the water slide, the water going down the slide is going to go faster. And the people are going to go faster too. All right. So increased discharge, increased velocity. All right, position in the stream. The maximum velocity is just below the surface, all right, where there's least friction. Because again, the bottom part of the stream, also known as the bed, that's where the most friction is going to be. All right. When the stream is straight, the velocity is greatest right down the center. All right. A big straight water slide, you're obviously going to go right down the middle of the slide. You don't end up on the sides of it. A meander, on the other hand, or stream curve, the maximum velocity is on the outside of the curve. All right. So in the case of this, if we use this water slide as the analogy, okay, so if you're on the water slide, you end up going up on the side walls on the outside of the turn. So it's the opposite way you're turning. So if you're turning to the left, you're going to be on the right side. If you're turning to the right, you're going to be on the left side of the slide. Well, the river does the same thing. So the maximum velocity will be always on the outside of the curve, opposite the way you're turning. So here's a kind of a picture to kind of put that together. So cross-section AB. This is a straightaway. So the greatest velocity is in the center. That's where your erosion is going to happen. All right. On the sides, it's slower, so that's where your deposition is going to happen. All right. So what happens on this, and I'm going to go draw it on the smartboard. You're going to get a shape, a cross-section profile down below. You're going to see what the bottom looks like because of this. So again, just to reiterate, so erosion, deposition on a straightaway, okay, so when you look at the side view or scuba diver view, I like to say is if you're swimming in the river. Again, the greatest velocity is in the center, so it's going to be deep in the center and shallow on the sides. So it's going to look kind of like this, right? And this is going to be the sand that fills in. So that's for a straightaway, like AB here at the top. Then we get to a meander, a different story happens. Okay, at letter C, that is the outside of the turn. Okay, so the greatest velocity, you can see the greatest arrow here. This is where the erosion is going to happen. The inside of the turn is where deposition occurs. So you're going to get a different story in the cross section down below. It's going to be deeper towards letter C, and then shallow as you get towards D. So it will fill in like this. Because this is erosion, this is deposition. All right, again, this was erosion, deposition, deposition. Okay. E to F, on the other hand, you're turning to the left this time. So the greatest velocity is going to be here. So erosion is on the outside here. Deposition will be on this side. So as a result, same thing down here. So translating to the side profile view, you're going to be shallow on the left side and deep when you get to letter F. So that's the way the sand would fill in. And if you go back to the original picture of the chapter, right, from the slideshow, you'll see here's the sand on the inside of the turn. Outside of the turn, you're going to see deeper water. So that it exactly happens. It almost looks like a water slide, all right? You can see it, all right? So inside of the turn, you'll always see sand build up. Outside of the turn, you'll always see deeper water, all right? And that's the general trend of this. So if we were to generalize this idea, where would erosion occur? Erosion always occurs where the velocity is greatest. So wherever the velocity of the river is greatest, and where would sediment be dropped or deposited? So deposition, that's the word. Velocity is least. So as water slows down, it's going to drop sediment right in its tracks. All right. Thank you guys for tuning in. Hopefully this helps. These cross sections can be a little tricky. All right. So just keep studying and keep looking at this and trying to figure it out. All right. Thank you guys for tuning in.